Hello everyone. Today we are going to study linear algebra, one of the most powerful and widely used branches of mathematics in engineering and technology. Whenever we use a smartphone, navigate with GPS, analyze medical images, design buildings, develop robots, or build intelligent systems, linear algebra plays an essential role behind the scenes. This unit introduces mathematical concepts that help for solve complex engineering problems in a simple and systematic way. First topic is eigenvalues and eigenvectors. These concepts help us understand how a matrix transforms a vector. Instead of changing in every possible directions, certain special vectors retain their direction and only change in magnitude. These vectors are called eigenvectors, and the corresponding scaling factors are called eigenvalues. Next, we will study the properties of eigenvalues and eigenvectors. These properties helps us analyze matrices more efficiently and solve engineering problems with less computation. After that, we will learn Cayley-Hamilton theorem, one of the most elegant results in linear algebra. This theorem states that every square matrix satisfies its own characteristic equation. Using this theorem, we can calculate higher powers of matrices and find matrix inverse more easily, making many engineering computations faster. The next topic is quadratic form. A quadratic form is a special mathematical expression that appears in optimization, energy calculation, and engineering design problems. We will learn how to identify different types of quadratic forms and understand their significance. Finally, we will study the reduction of a quadratic form into canonical form using orthogonal transformation. This technique simplifies the complicated quadratic form into a standard form, making analysis and interpretation much easier. Throughout this unit, we will focus on understanding concepts through step-by-step numerical examples, engineering applications, and previous gate questions. Now let us see why linear algebra is important for engineers. Eigenvalues and eigenvectors are used in structural engineering to study vibrations in bridges, buildings, aircraft, and mechanical systems, ensuring their safety and stability. In artificial intelligence and machine learning, they are used in principal component analysis to reduce large data sets and improve the efficiency of learning algorithms. In electrical and electronics engineering, they help analyze electrical circuits, control systems, and communication networks. In biomedical engineering, linear algebra plays an important role in MRI, CT scan reconstruction, ECG signal processing, and medical image processing. The Cayley-Hamilton theorem is useful for finding matrix inverses and simplifying matrix computations in engineering applications. Quadratic forms are applied in optimization problems to minimize cost, energy consumption, and improve system performance. Finally, orthogonal transformations are widely used in computer graphics, robotics, image processing, and wireless communication. So, linear algebra is not just a mathematical topic. It is a powerful tool that helps engineers solve real-world problems across many fields. Now, let us solve some latest gate questions. The matrix A is given by A is equal to 4, 0, 0, 6. Then, the eigenvalues of A are dash. Option A, 4, 6. B, 4, minus 6, C, 6, 4, D, 24. What is the answer? Since it is a diagonal matrix, the eigenvalues are the diagonal entries. So, answer is option A, 4, 6. Next question. If a 3 by 3 matrix has eigenvalues 2, 5, 7, then the trace of A is option A 14, B 25, C 30, D 18. What is the answer? Trace of the matrix A is equal to sum of the eigenvalues. Therefore, 2 plus 5 plus 7 is equal to 14. So answer is 14. Let us see one real-time engineering application. In electrical and electronics engineering, the eigenvalues are used to study the stability of control system, power system and electrical circuits. Now let us consider a simple electrical system represented by the matrix A is equal to -2, 0 and 0, -5. This matrix represents the dynamic behavior of a control system. To solve this problem, first we need to find out the eigenvalues. For eigenvalues, we have to take the characteristic equation. So the characteristic equation is given by determinant A minus lambda I equal to 0. So we have determinant -2 minus lambda 0, 0, -5 minus lambda equal to 0. Now expanding this determinant, we get lambda 1 is equal to -2 and lambda 2 is equal to -5. This simple real-time example demonstrates how eigenvalues help electrical engineers predict behavior and stability of the electrical systems before they are actually built. Similarly, matrices and linear algebra concepts are widely used in many engineering fields such as artificial intelligence, computer graphics, robotics, signal processing, structural engineering, biomedical engineering, and control system. Throughout this unit, we will explore these concepts and learn how to apply them to solve practical engineering problems effectively. With this, we come to the end of today's introduction section. I hope you have gained a clear understanding of the importance of linear algebra and its engineering applications. Remember, every great engineer begins with a strong mathematical foundation. Thank you for watching. Keep learning, keep exploring.